Sam's house has an apple tree and an orange tree that yield an abundance of fruit. Using the information given below, determine the number of apples and oranges that land on Sam's house. In the diagram below, the red region denotes the house, where S is the start point and T is the end point. The apple tree is to the left of the house, and the orange tree is to its right. Assume the trees are located on a single point, where the apple tree is at a point A and the orange tree is at point B. When a fruit falls from its tree, it lands d units of distance from its tree of origin along the x-axis. A negative value of d means the fruit fell d units to the tree's left, and a positive value of d means it falls d units to the tree's right. Given the value of d for m apples and n oranges, determine how many apples and orange will fall on Sam's house. For example, Sam's house is between 7 and 10. The apple tree is located at 4 and the orange at 12. There are 3 apples and 3 oranges. Apples are thrown apples units distant from A, and oranges units distance. Adding each apple distance to the position of the tree, they land at 6, 7, 0. Oranges land at 15, 10, 8. 1 apple and 2 oranges land in the exclusive range 7 to 10, so we print 1, 2. Function description. Complete the count apples and oranges function in the editor below. It should print the number of apples and oranges that land on Sam's house, each on a separate line. Count apples and oranges have the following parameters: S, starting point of Sam's house location; T, ending location of Sam's house location; A, location of the apple tree; B, location of the orange tree; apples, distance at which each apple falls from the tree; oranges, distance at which each orange falls from the tree. Input format. The first line contains 2 space-separated integers denoting the respective values of S and T. The second line contains 2 space-separated integers denoting the respective values of A and B. The third line contains 2 space-separated integers denoting the respective values of M and N. The fifth line contains n space-separated integers denoting the respective distance that each orange falls from point B. Constraints: 1 less than equal to S, T, A, B, M, and N is less than equal to 10 to the power of 5. Minus 10 to the power of 5 is less than equal to D, which is less than equal to 10 to the power of 5. A is less than S, which is less than T, which is less than B. Output format. Print 2 integers on 2 different lines. The first integer, the number of apples that fall on Sam's house. The second integer, the number of oranges that fall on Sam's house. Sample input: 7, 11, 5, 15, 3, 2, minus 2, 2, 1, 5, and minus 6. Sample output: 1, 1. Explanation: the first apple falls at position 3. The second apple falls at position 7. The third apple falls at position 6. The first orange falls at position 20. The second orange falls at position 9. Only one fruit falls within the region between 7 and 11, so we'll print 1 as our first line of output. Only the second orange falls within the region between 7 and 11, so we'll print 1 as our second line of output. This is a Java solution for the apple and orange problem on Hackerrank. The problem requires counting the number of apples and oranges that fall on a house with a range between S and T. The program takes as input the starting and ending points of the house, the location of the apple tree, which is A, and the orange tree B, and the number of apples and oranges that will fall from the trees, which is M and N. The problem iterates over the apples and oranges using a loop, adding the distance from the corresponding trees to the current position, and determine if the final value is within the range of the home. Upon confirmation that the associated count variable is raised, the program prints the number of apples and oranges that fell inside the house before concluding.